It's just a glare that I have a problem with. Yes. 7 minutes. The restroom now. I have the introduction.
Oh, no.
She just did it.
I'm just
One part of one.
But not on the-
I did 1,500 divided by 960. I got 1.5625.
Yes, that's great.
I know it's N8.
Oh, but she went around with two. Okay.
That's your-
Yeah.
Did you compute that?
What about teaspoon?
Okay, so if it's in mg, you convert to 50 milligrams to grams first. You convert that to grams.
Why is that?
And then because remember, grams over ml.
Oh, you can't do microgram.
Oh, that's the legal source. Yeah,
That's what lots of
milligram. So convert that milligram to gram.
I think the N. So that would be.
So come down. And then convert the tablespoon into an ounce. Don't forget your unit.
Yeah.
The tablespoon to unit.
So we divide, one different.
I know. Five minutes.
Is the restroom now? It's a big marathon.
So percentage of ground, that's all. Or that's the anything outside of that, no. No micrograms, no micrograms. One point six.
That's how it got along.
Okay.
Yeah.
It says that it's saying that there's a provider of optimal volume. It's not, it looks like it's.
Yeah.
I put. I think you're wrong. And then the bottom one is saying that it's here, it's 300. Right now.
But
And then I use this. Right now.
So we got one issue before we got. And
So we're gonna ask me. So I do smoke it one for 60. Now, all of the documents, we convert the first one to the.
Not
2 minutes.
So you have to plan. Same thing.
Yeah, it's basically.
Oh, no.
If the answer is 4.5 and then convert milligram. Convert becomes out and milligram.
Recording times.
Okay, recording.
This is brains. Oh, that's the one.
Brings.
Down, not that tall anyway. That's in the glare.
So we do ratio proportion with
Both videos should be out by tonight.
And it's 9 o'clock. Good morning, pharmacy. Okay, so yesterday,
If everyone
cut it out now. Okay, yesterday we talked about percentages as a measure of strength or concentration of a drug or a substance. Okay, percentages because it's the foundation for dilution and alligation calculations. Okay, I want to differentiate dilution from alligation first. We talked about dilution yesterday. We talked about alligation yesterday, a little bit, right? But it's mostly percentage. Before I move on, is there anybody who's still struggling with calculating percentages of drugs, solutes in the IV bag, the sodium chloride and the dextrose in the IV bag? You're still struggling with that? Okay. So I'm gonna say 30 minutes today after class to do tutoring. but don't expect that tutoring is going to be a full new class. When you come to tutoring, you come with questions that you want solved, okay? Because you have your 4-hour class with me, okay? So like, it's not, can you do it all over again? No, come with a specific question, and then I'll show you how to work that, because that example, that demonstration will help you understand the others as well. Okay, yesterday I didn't want you to leave the campus without knowing percentage. Okay, that's why we spent a lot of time there. Anybody else having problems with percentage? No? Okay. This new video should be out by tonight. Hopefully I can post it tomorrow. Okay, to help you guys, because as requested, everyone we possibly fast forward me. Okay, dilution. When you say dilution, it's making a substance or a drug, okay, that's concentrated, meaning can be pure, okay, to a less concentrated strength, okay. So from high to low strength, which means from 100 to 80, from 100 to 10, from 80 to 40, from a high to low. That's dilution. So I always ask this. How do you make a coffee diluted?
Water.
Thank you. See? It's I never, okay, so always I ask that question. How do you make a coffee diluted? Most of the time, I'm gonna get an answer, add more creamer. Right? But some people drink black coffee. Okay, so add more water is what I was expecting when I started asking that question. Okay, that is dilution. Okay, because by adding water, you make your coffee less strong. I want my coffee strong. Okay, but if you think that this is too strong, you add more water. In the case of Karen, she adds more creamer. Okay, so dilution is making a higher concentration to a lower concentration. Remember, yesterday we were talking about concentration and strength. Alligation, on the other hand, is there are two concentrations available, one high and one low, and usually you're asked to make the middle concentration. So the question is, like I said yesterday, how much of the higher concentration do you need, and how much of the lower concentration do you need to make the middle concentration? Hello? So formula wise, I like using the formula for dilution. C1 V1 equals C2 V2. C1 V1 equals C2 V2. Initial concentration, C1. Initial volume, V1. Final concentration, C2. Final volume, V2. You follow? Okay. What's the initial concentration? Is it the higher concentration or the lower concentration after I just described what dilution is? This will be the higher one. And your final concentration will be the lower ones. Do you know how to solve problems like this? Given this formula, right? It's finding the x. If you have 3 variables, you can figure out what your C1 is, what your V1 is, what your C2 is, what your V2 is. Okay? I don't want to go through basic math. Okay? At this point, since you're in this program, I would like to think, and I believe that you've knocked down your basic math. Okay, C1 V1 equals C2 V2. I use this formula when I'm asked to dilute. Because it's easy. Other books, which I don't like using these abbreviations, initial volume times initial strength. Doesn't matter, I mean, formula wise, but I want you to know concentration, like what we were talking about yesterday, is the same as strength. So other books will write it as initial strength times initial volume equals final strength times final volume. Exactly the same. Okay. But I've learned in pharmacy school, C1V1 equals C2V2, so it's a habit. But I want you to know that we're talking the same exact thing, same language. Okay. So remember that your one or your initial will always be the higher one, higher concentration, because dilution as it's defined is from a higher concentration to a lower concentration. Follow? For alligation, on the other hand, right off the bat, you think about tic-tac-toe method, correct? Okay. And the tic-tac-toe method, we put the higher concentration here, correct? And where's the lower concentration? Right over here. Is that correct? What do we put here in the middle? The middle concentration. Say, for example, you're given a problem where there's 90% of the substance available. Okay. And there's a 20% of the substance available. What a problem, right? Why can't they just have the exact one? Okay. Nowadays, okay, the pharmaceutical companies create the exact dosage, the exact strength that the doctors usually prescribe, so they can help with minimizing medication errors. But when you're working in a larger scale pharmaceutical company, compounding setting, not always that you have the exact strength of the drug, but that shouldn't cripple you because you know alligation. Okay, so say for example 90 and 20, and here goes the middle concentration. Okay, you need to figure out, you need to mix the 90% and the 20% to get 50%. That's just an example of an alligation. Okay. Follow? The problem here is how much of the 90 do I need? And how much of the 20 do I need to make 50? That's alligation. Follow that? Not always. Okay. Whatever is being asked of you. There's a high and a low, and then most of the time you're being asked of the middle. Okay, for alligation. That's why we like using tic-tac-toe method for alligation. I'm gonna stop here. So Miss L, this will have 2 concentrations. Correct. This will have 2 percentages. Correct. This has 3. Correct. However, I want you to remember this. You can use alligation or the tic-tac-toe method as a way to solve dilution problems. And I can show you that as we get through your lecture packet. To your practice problems. What do I mean by that? There are 2 important details that you need to remember. In dilution, we add water to make a higher concentration to a lower concentration, correct? You have to remember that water will always have a concentration of 0%. So with me saying that you can use alligation or the tic-tac-toe method for a dilution problem is true. By using the lower concentration, if it's not given, you just have to know that water is 0%. So water 0% will go here. You follow? Okay. It's not always 3 concentrations given, right? It can be 2, but you can use tic-tac-toe. Are you following? Okay. Another thing that you want to remember is a pure substance is 100%. Mentioned this yesterday. So there may only be 2 concentrations given, because you have to know that water is 0, and you have to know that a pure substance will always be 100%. That clear? Now you can plug in the numbers. If it's a pure substance, then you'll have to have the 100% on the higher side. Clear? Okay, now let's put this into action or an example. You ready? Okay. A lot of the questions on the PTCE or ExCPT doesn't seem like a percentage question. I mentioned this yesterday, but they are, and they fall under the patient safety category. Okay. Doesn't seem like it because it can be given strength, can be given in a ratio form. 1:20,000 strength. That automatically tells you, learning from yesterday, that 1 pertains to grams. Did I say 10,000 or 20,000? And 20,000 pertains to 20,000 ml. Or 1, if it's an ointment, a semi-solid, 1 pertains to 1 gram, and the 20,000 pertains to 20,000 grams. Remember yesterday? Or if it's volume over volume, it means that it's 1 ml over 20,000 ml. Those are things that you need to remember. No matter what, your percentage will always be weight over weight, volume over volume, or weight over volume. And when we're talking percentage of strength of drugs, your weight will always be in grams. Those invisible letters and numbers. We're talking percentage. Your weight will always be in grams, and your volume will always be in ml. Clear? Okay. Let's do some practice problems based on your packet. Give me 1. Oh, here are the numbers that you want me to solve, correct? Number 1, number 4, number 26, number 5, number 29, number 30, and number 36. Any more requests?
You can erase the 1 and 4.
No 1 and 4.
Oh,
So he needs that one. Remember these things, remember your percentage, remember all these things. Okay, so in a test, when I'm taking the any major exam, if it did specifically ask me to use the tic-tac-toe method, and I know that it's a dilution problem, because it's asking me a question about a higher concentration going to a lower concentration or using water, I use this to simplify my life. Okay, but some students like using the tic-tac-toe method even for dilution, and that's fine. They use 0% for water, 100% for pure substance. That's all you need to remember if you want using the tic-tac-toe method. I gave you lecture packets yesterday on the alligation. Okay, I'm going to tweak that a little bit. That was written by another instructor, but I'm going to show you another way that students said is easier when I showed it to them. Okay, it wasn't the way I learned it in pharmacy school, but I listened to students. Okay, how can I help you guys by tweaking this? And you'll still come up with the same. Let me pull up my packet. Number 1.
That one was 1.
Number 1.
I'm good on that.
You want number 1?
No, I'm good on that one.
I want to show it though, okay, because I was talking about this. How many milligrams of beryllium chloride are needed to prepare? So here are my variables. 3 liters of 1:30,000 solution. Those are the only numbers that were given to me. Can I solve it? Yeah. How do I solve it? Multiple ways, actually. I can convert this to percentage if I want to, and then use this formula. Can I do that? Coconut. Yeah. I always just have to remember, most of the time with that solution, it's weight over volume, by the way. This is an invisible sheet right there. Yeah. And this is an invisible ml right there. What was the problem? What was my X? How many milligrams? Right? That was my problem. So I can just simply use ratio and proportion as well. Is that right? We did ratio and proportion. But when you use ratio and proportion, it has to be apples to apples. So I got a 1 gram here over 30,000 ml, follow, equals, next, X grams over 3,000 ml, because your liters have to be converted to ml to make it apples to apples. Good job. Okay. Now we do cross multiplication. 3,000 divided by 30,000. That answer will be in grams first. What is that?
0.1.
0.1 grams. Take note, let me tell you this, on the PTCE, they'll give you 0.1 milligrams as one of the options. So you off. Why? Because this is the initial answer you're going to get. That's why I make it a habit to put the unit. And what are your options? All in milligrams. Which means a common mistake is choosing the 0.1 milligram answer, which is wrong because you set up your problem this way, correct? So these are things that you gotta remind your brain. Don't stop there. So to eliminate that problem, always put the unit. And what do? We convert this to milligrams. Dimensional analysis, ratio, and proportion. I don't like it. So converting this to milligrams would be 1 gram, 1,000 milligrams. That means I've used alligation here. All right, this will be what?
100 milligrams.
100 grams. Who got 100 milligrams? Hands up. Why did I say I can convert my 1:30,000 into percentage? Then what formula am I going to use? 1/30,000. You're going to get an answer in percentage as well. I'm telling you that so that you know your options can change. Right now, it's asking you how much in milligrams. But if the options change to percentage, you can easily convert this into a percentage. You follow? So you do that, 1 divided by 30,000 times 100. We talked about this yesterday, right? Because it's in the correct format. Okay, any questions? Okay, number 2. Very similar to number 1, correct? What's the answer to number, so the answer to number 1 is B, 100 milligrams. What's the answer to number 2? Do I have to do number 2? Yes, no, maybe so. No, very similar, okay. The answer to number 2 is 2.56 grams. Who got that one? Hands up. If you don't say anything, I'm not gonna go over it. Number 3, easy conversion, right? Convert 1,200 milligrams to grams. 1,200 milligrams to grams would be 1.2 grams. I always tell you, don't multiply or divide, right? Because many students multiply when they have to divide when they have to multiply, and it's a common mistake, and it's a dangerous mistake. So choose one of the 2 things, ratio and proportion or dimensional analysis. To me, if you know how to use ratio and proportion or dimensional analysis, that extra step validates that you really have to multiply or divide. It helps lessen medication errors, possibility of medication errors. It's just an extra step. What's an extra step to save life or lives? Who got 1.2 grams? Hands up. Okay, number 4. Yeah, here we go. You want me to do this? Yes, no? Maybe so. Okay. Do this. Done? I'm moving on. And then after this, I'm going to have you guys go to the board. Because sometimes you don't understand the way I did it, but when a classmate tells you how to do it, you understand. Like sometimes our kids don't listen to us, but will listen to any YouTuber. It's like the word of God when a YouTuber tells it. Okay. See. Number 4, how many grams of 12%, I got here 12%, yellow mercuric oxide must be added to 30 grams. Hello. Must be added to 30 grams of 1% yellow mercuric oxide ointment to prepare. I always put to make. Okay. 5% ointment. Take note. Content wink. UNG abbreviation. UNG lowercase means ointment. Unguento, just in case. Okay, UNG abbreviation. Specifically said use the alligation method. So we got to do tic-tac-toe, correct? Oops, I need more room. Done here?
Yeah.
What did I say? When using the tic-tac-toe, you should have a higher concentration and a lower concentration to make the middle concentration, okay? Read a problem again. How many grams of 12% yellow mercuric oxide must be added to 30 grams of 1% yellow mercuric oxide ointment to prepare a 5% ointment? Do I have 3 percentages? Yes. Okay. What do I put here? The higher one, which is? When I see that to make right off the bat, I know that that should be the one in the middle. But the way to check is there's another lower concentration, correct? And then to make, this is when I do the tweak. Okay. So higher, lower, middle. That answered it, correct? The next step is to do the crisscross method. Okay, subtract given where your final answer will be absolute values. Okay, 12 minus 5 is 7. Okay. All right. You see that? Absolute value, so I don't have to go this way. Kind of, but it's easier. 5 minus 1 is 4 parts. See that? Okay. This is when the tweak happened. 7 plus 4 is 11 parts. But so I'm not confused, this is what I'll do. Okay, I'll bring the 5% here and put it equals here. There's a reason why I did that. Okay, because this I want you to know goes this way. Okay, and this goes this way. You're not confused. There's another given. What's the given one? 30 grams. So where's the 30 grams? On the 1%. Can you see that? So what I put here will be 30 grams. That's why I did that. So I don't get lost. Okay. This is my way. You're not going to find it in any book. 30 grams. Now, what was the question? How many grams of the 12%? This is actually the X grams, correct? Because this is the 12% row. Follow? Can it work this problem?
Yeah.
Yeah, okay. This is when the tweak happened again. If 7 parts, this is my way. Okay, because on the book it's different. It's gonna be in fraction form. But because students told me they understand ratio and proportion better, my pharmacy professor said there's not a single problem in math that you cannot solve using ratio and proportion. If 7 parts is to 30 grams, what do I do?
Then 4 parts is the X gram.
Woohoo! 4 parts is to X grams. Isn't this ratio and proportion?
Yes.
But to those of you having problems with fractions, you can do it this way. What happens next? Cross multiply. 4 times 3 is 12, so that's 120 equals 7x divided by 7 is
17.1.
17.14
14.
14
Mhm.
grams. You answered the question. You answered the problem because the only question in the problem was how much 12% do you need to make 5% ointment? But I'm going to make it a little bit more complicated so that you can answer any question on the PTCE. You got this too, right?
Yeah.
Sometimes the question is, how much is the total? Once you've set this up, all you need to do is to add the 2. That means that 5% ointment, the final weight of that ointment will be 47.14 grams.
Okay.
Did you see that? Did you see that? Because sometimes the question is, how much is this ointment final volume in total weight? Remember, ointments are semi-solids. That's why it's weight over weight. See that? I will pause here for 30 seconds so that you can stare at it and absorb it. But did you see how I put this in a row so that I know this pertains to 12? Put this in a row so that I know this pertains to 1. I brought down my 5. That's why I said you won't find this in any book. Okay, so that you can answer this question just in case it asks you of how much is the total weight of this ointment. This total, there's another possibility. if this ointment, they said the final weight is 47.14, and you're given this, you can simply subtract 30 grams from 47.14, then you get 17.14. See that? That's why I said you've got to know your terminologies. Solute, solvent, solution, diluent, your diluent. Okay, it's also in the practice problems. Those who asked to do four, is that number 4? You understand now? Yes, no, maybe so. Number 4. Did you get number 4 now? The way I saw this was different when I was back in pharmacy school. But through 15 years of teaching, listening to students, okay, the ratio proportion clicks to them better. So I'll try to do it ratio proportion way. Did that click better? Rather than the fraction way?
The 30 grams you like the grams that they give you always put that on the bottom, correct?
No. You have to identify it wasn't the given. It wasn't the problem. A lot of times people get anxious and overwhelmed because word problems are wordy. Yeah. And sometimes it will tell you a story, but it's just asking you to calculate or convert a Fahrenheit to a Celsius temperature. So read the problem over and over and over. The 30 grams was given. It said on the problem. Did you see how I set up my variables? 30 grams off 1%. And then I started listening to the numbers, making the numbers talk. I think I'm schizophrenic, but the numbers talk. Okay. If you know the language of math, they talk. Equals means is, off means multiply. That's why I told you I don't like memorizing formulas. Chemists, pharmacists, biochemists, they make the formulas, they work backwards. Think about Albert Einstein. E equals mc squared. Did you say that? No. There was a final product and he worked it backwards. That's why I created that formula. If you just set it up step by step like that, it won't go wrong. As long as you plug in the numbers correct. Like I plugged in my 30 grams square at the 1% row. You see that? Because if I plug in my 30 grams anywhere I want, you're going to have the wrong answer. Because it said exactly 30 grams of 1%. So that's why I started making this rows. Number 5. Number 5, here comes the diluent terminology. The diluent is the amount of liquid, usually water. Liquid, usually in the form of water. Amount of liquid, usually in the form of water, that you add to dissolve that powder. It can be liquid and liquid too. But the diluent will be less than the solute, okay, is less than the diluent. Okay. Okay, number 5. You didn't want to help here. Yeah? You do, you don't?
Yeah.
That's not in there. Oh, there you go, number 5. Because the 26 came before 5. We know how to count. Okay. A lot of times the problem is you overcomplicate it. You overthink. And you just say, I don't know, after reading it one time. Doesn't work like that. Sometimes I have to read a word problem 3 times. 5 times. 2, for me to understand what does this really want. That's why I underline numbers, I encircle numbers. Okay. Number 5. 5 ml volume is added. After the something, you do the others. The 5 ml volume is added to a vial containing 2 grams of a drug for injection, resulting in the final volume of 5.8 ml. What is the concentration in, specifically said, milligrams per ml of the drug in the reconstituted solution? This is easier to picture if you're doing IV already. Yeah? Okay. Why is it easier to picture? Because you will see that the vial comes in powder form. Yeah, the drug in the vial comes in powder form. And that's what it's talking about as the 2 grams. This powder is 2 grams. Okay, but it's saying that the final volume is 5.8 ml. Let's go back and review percentage. Percentage will always be weight over weight. Percentage will always be volume over volume, or percentage will always be weight over volume. The most common one is this one. Okay, this is used for ointments, creams, semi-solids. So weight over weight. And what did I say? Your weight, no matter what, will always be in grams over ml. You want to get the percentage, that's 100 times 100. Okay, and the solute will always be the numerator, and the ml at the bottom will always be the total solution. What was the question? What was the question? What is the concentration, right? And I just talked about the concentration. So it will be, this is your weight. Weight of solute is 2 grams. Is it in the correct unit already? Yes, grams, not yet. For percentage, we're talking percentage, okay? Percentage weight over volume, is it in grams? Yes. Is this one in ml? Because it's final volume. 5.8, correct? ml. Want to do the math here? That's fine. When you do the math here, grams per ml, this is also concentration, so you know. What's the answer? 0.345 grams. I have to pick up this per ml, correct? That wasn't the question. The question was milligrams per ml. How difficult it is to convert this particular answer to milligrams. Not at all. What do you do? Then you're left with your milligrams per ml. What happens? It becomes
345 milligrams per ml.
cool. What happens to the 5 ml? You don't need it. If you know the formula, that it's always going to be total. Or final volume will always be total. Total weight, total solution. This matters when it asks you to this. Powder displacement. This is a common question on the board exam. Okay. Powder displacement. What's powder displacement? You know, when we were in elementary, there's a beaker, did an experiment. There's water. Okay. The water is at 100 ml level. Okay. A pebble was dropped. The water level changed to 110 ml. What is the powder volume? What is the volume of this? 10 ml, because powder volume or displacement is final volume minus initial volume. So your final volume is 110 ml minus 100 ml. The answer is 10 ml, meaning this pebble, aka in our terms, the drug, okay, displaces 10 ml. Okay, so when you're asked on the PTCE, ExCPT, this is the formula. Powder displacement, powder volume is final volume minus initial volume. Okay, here's a vial, say for example with 1 gram. Okay.
There's a question in 25.
That's related to this one. Okay, good. Number 25. Here's a powder that's related to this one. Okay. Says the final volume of this powder turns out to be, say for example, 10.1 ml. Okay. You injected 10 ml of diluent. What is the powder volume of this powder? It ended up 10.1 ml. 0.1 ml, 0.1. That's powder displacement. Roxy said question number 25 pertains to what I'm talking about, right? Clear? This 5 clear? So we got 1, 4, 5. Done. Number 6. Easy. What is this? It's a simple conversion and the quantity to be dispensed
Per dose.
per dose.
Yeah.
So amount of drug that needs to be dispensed, quantity to be dispensed per dose. Okay, then you convert. Okay, answer number 6.
C.
Letter C. You receive an order of cowpactate 15 ml BID PRN. How many tablespoonful is in 1 dose? How many tablespoonful is 1 dose equal to? And the answer is
1
1,
tablespoon.
because it's per dose. Actually, you don't need to calculate because it's just per dose. It's telling you that per dose is 15. But if it asks you per day, that's when the BID comes into play times 2. Is that clear? Okay. So those who did it wrong on their quiz number 2, gotta remember that. Okay. I put correct answers on your quizzes for a reason. Okay. Number 7. Easy. Been talking about this since yesterday for 4 hours. It's just asking you percentage. If there are 30 grams of dextrose, it's already given. Okay. In grams already. In 500 ml, there's an ml, right? In the correct units already. What percentage solution would it be? It's going to be a simple divide the grams divided by ml times 100. You get your percentage. That's why I said many questions on the PTCE are disguised but they're actually percentage questions. So if you have to master like what particular math topic, it's going to be percentage. Number 8. We did this yesterday. How many grams of dextrose are in 750 ml of D10W? 10 means 10%, right? Right off the bat. So if D10W is 10%, that's how I do it. Right away, I'll put 10 grams over 100 ml. That's what it meant to me. That's how the numbers should talk to you. Okay. But it's not only 100 ml. What's the volume? 750. So simple ratio proportion. 10 times 750 divided by 100. Got it? And the answer is
B.
B, 75 grams. I'm done. I'm tired. Number 9. I'm gonna start calling you. Okay, let's see. And then we go on break at 10. Okay. Raise the board, please. 2 people at the 2 people at the same time. 9 and 10. Number 9 will be Jen. Number not a friend. So a senior and a freshman. 9 and 10. We'll see how much we can do until 10. Then we go on a 30-minute break. Who's pulling their hairs right now? Oh my goodness.
Oh, no, my friend.
It's okay. Just put a divider line on the board. You can erase the copy. 9 and 10. Another one that just dies, right? Another percentage problem. If you remember that percentage will always be weight over weight, weight over volume, volume over volume, and the weight will always be in grams, and the volume will always be in ml, you shouldn't go wrong. Okay, no matter what. But remember, the most common percentage used is weight over volume. Why? It's usually a powder dissolved in water or in a diluent. Very easy, right? Number 9, explain, Jen. Jen, explain.
I did that.
500 ml of normal saline. You guys are lucky. Normal saline, it says that there's 0.9% sodium chloride solution. On the PTCE, that doesn't show. Okay, so it's going to be then 0.9 G over
100 ml
proportion
xg over 500 ml, then cross multiply and divide, and I got 4.5 grams.
We got 4.5 grams. Hands up. Good job. Number 10, Jonathan, can you explain? It's so hard to see. Green. It's okay.
All right.
It's
So
fine.
it's,
I'm just being a one-year.
It's 40 grams and it's 500 milliliters of water. So it's like the grams and the weight and the volume are all in the correct forms. So I just put it over 40 grams over 500 milliliters. And I multiplied that by 100 and I got the 8%.
Correct. Simple. If you know the basics of percentage, it's in the correct unit. You set it up correctly, grams over ml. Note that it's converted to a percentage. You multiply that by 100. Done. Who got 10 correct? Hands up. 11 and 12 on the board. I think we still have 5 minutes. 9 minutes actually. Here you go, Roxy, 11. 12, Geo, you got 12?
Yeah, oh, yeah.
Yeah, percentage,
that's
you
good.
should get it.
Yes, please.
Jonathan.
We watched it.
Okay, Kyle, if you guys are in trouble, I'm in trouble. So I'm not gonna attend the meeting today because none of you are in trouble on attendance. I kind of frees up my 12 o'clock so I can do tutoring, okay? When Gio's in trouble, it's not gonna. So we learn to have your sisters not. It was so fast when I Jonathan is the logical side and this Theo is the creative side. You can tell real fast. This too. It's nice to be complimented.
Yeah.
Plain Roxy.
The question is, if there are 5 grams of zinc in 75 grams of ointment, what is the percentage of drug? So I divided 5 grams divided by 75 grams times 100, 86.66%, and round off will be 6.7%.
Option is closest is 0.7. Correct. Isn't that a percentage problem again? Okay, so what is that? Percentage what? Weight over weight. Remember I told you when it's ointment, lotion, cream, like your semi-solids, usually ointment, okay? It's weight over weight. But lotion, most of the time are in both units, volume and
Small.
Gia,
Alright, so yeah,
explain.
I got D 1.7. So first thing I did was, I saw that the question was in 250 milligrams, so I converted that into gram, which is 0.25. And then 1 tablespoon, I know that's 15 milliliters. So that I divided the 0.25 of 15, and I got 1.66 repeating, which is 1.7.
Correct. So the first thing he did was to make it grams over M. Because that's how percentage is shown. Good job. 11 and 12. Still have 5 minutes. 13. Gina. 14, Matea. Yeah. This is gonna be the last one, then we go on break. There's another one. Oh. It's so hard. Students told me that, like on the video, it's hard to see the red. Learn.
I did mine differently.
That's okay.
Okay, I'll just do it roughly.
Yeah, take notes. Mateo was absent yesterday, so we'll see how this one worked out. And it's a percentage problem. Do it. Explain, Gina, real quick, 13.
So there's in 1 liter, it's 1,000 ml. So I just put 25 ml over 1,000 ml, divided it.
And then multiplied it by 500. Same process all the time. And this one is percentage what? Percentage what?
Liter, volume or volume.
Volume over volume. You see, like too much practice on percentage, okay? Because PTCE disguises a lot of this problem. Okay.
So I wasn't sure exactly how to do it, so I kind of just worked it out from the way I knew
like how, and I just tried each answer differently and like put it in. I put it like, I plugged in each answer, so then I ended up with 1.2 grams.
Okay, but really, it's weight over weight, okay? You can just do 2%. Oh, okay, let's make this one. Gotcha.
That was before you started going over the other ones, so then it started making sense to me, but
She got it right. You
I just
see?
started plugging in to get,
And that's what we do sometimes when we're taking a test, right? We don't know how to do it, so we start checking each answer. We start calculating. We do what we gotta do, which is smart. She wasn't here yesterday during that topic. But for this one, how many grams of hydrocortisone are in a 60 grams of a 2% ointment? This is how I do it, because the 2% was there, correct? And this is how it should look like. 2%. How many grams of hydrocortisone are in a 60 grams of a 2% ointment? Did you see that? And this is X grams, because I know that it's weight over weight, correct? Times 100. What can you do to make it simpler for those who struggle? I'll just convert this percent to decimal right away. How do I do that? What's 2%? 0.02 equals xg over 60g. Another simple way to do it. What do you do next? Is that right? You gotta remember the percentage can be converted to decimal. Your fractions can be converted to decimal. Your ratios can be converted to fractions, thus can be converted to decimals. So if you're having a hard time, those things will save you.
I did it before, I just want to verify if that's correct.
Go, do it on the board. It might just click for others or for the other freshmen.
Yeah. Yeah.
You get it.
Yeah.
Lost one black.
I wrote it down,
Very good.
and then, check.
Did you see how his brain worked? I cannot force one way to you guys. That's why I don't like those instructors, professors, and teachers who tell you have to do it this way or I'll mark you wrong. I'm never that teacher. And I'll never do that to you because I've always had a different way of solving problems. My son sometimes gets frustrated at me if he solves a problem this way, and then he said, Mom, how do you do this? And I'll explain it to him, and it's like, I solve it this way. Like, okay, I'm not gonna argue with you, not at all. That's all. Why? He got the same exact answer. His brain just processed it differently. Okay? And it's fine.
I did it different.
Okay, one more before we go on break. Roxy and then Megan. This might work because I still see some faces on freshmen. It's not yet clicking on them. Okay, so different ways are fine. Can you erase 13 so they know that we're dealing with? Are we dealing with 14? Yeah. Okay. Different ways. I lost that one. It rolled underneath. Then I couldn't find it. There we go. Gonna go to the first supplier. Control, and you're doing.
It's right there, it's underneath Megan.
Oh, there you go. Okay. We'll erase this, okay? Taya wasn't here, so the basics of percentage she hasn't gotten. Right? So she's testing. She did what she had to do. Test each one. Okay? But you got different ways. Come back up, Jonathan. Explain how your brain processed this problem and solved this problem.
So I know that it was asking for 60% of it was asking how many grams of hydrocortisone are in 60 grams of 2% ointment. So I put both of the percents on the bottom and both of the grams on the top, and I had a 60 grams of 2%. How many grams of? So I asked her. I knew it was how many grams it was asking for the 2% ointment, so I put the X on top of the 2, and the 60 was the total amount of grams that it was. I put that above the 100, and I just cross-multiplied everything, and I got these two numbers. I divided by 100, and I got the 1.2.
Did you?
2 grams.
Megan's. This usually is what's gonna click because of what we've been talking about. Remember how I told you percentage? Multiply that by 100, make it up here. So ratio and proportion of sorts, but converted the percentage to weight over weight.
I usually do things the long way, so I did.
But just so you know, okay, both of them got 100% on the quiz. Freshman and sophomore. So that's why I said I do not discount anyone and how they process the problem.
Okay, so it gave 2%, so I know that's 2 over 100, so I just did 2 grams over 100 grams, and then ratio of proportion. So we're looking for X grams, and they gave us the 60 grams. And then I cross multiplied it up.
Very good. So here, this should be what's clicking based on what we were talking about yesterday, but I cannot force that. This equated to 2%, isn't it grams over grams? Or 100 grams. This equated to saying weight over weight, but this is your total. That's why I should put it on the denominator. Okay. Roxy's a different way. Senior, let's go. Raise your flag.
I guess I went on the shortcut way.
She likes the long way, she likes the shortcut, and that's fine, right?
Based on the question, it says 60 grams off 2%.
There you go. That's when I said, let the numbers talk to you. Equals means, is means equal, and off means multiply.
So yeah, I multiplied 60 grams times, I converted the percent to decimal.
Correct.
So I get 2.22, multiply that, I got 1.28.
2% converted to decimal, you just said you could convert percentage to decimal, she did. 0.02. There's a word off of 60 grams. Simple. Yeah, so many different ways, but all got the same exact answer. Okay. Good job, guys. Let's go on break, 30 minutes, come back at 10:35. Yes. The numbers that are here, I'm still gonna go over them. Okay.